All right, so we're going to go ahead and add some linear expressions. The essential question for this one here is how is adding linear expressions, excuse me for a second, similar to simplifying expressions? How are they similar? Okay, so here we go. Linear expression, what the heck is that? It's an algebraic expression in which the variable is raised to the first power and the variables are not multiplied or divided. So whatever the letter is, it's got to the first power and that's it. So here are some examples of linear versus nonlinear. So we've got 5x. That's linear. 5xy, not linear because you've got two variables. You can only have one. This next one, 10x minus 3. Yeah, that's 10x to the first power. That's good. There's no multiplication going on here. Here to the second power. No good. That's x times x, not linear. X plus 9, that's also linear. X to the fourth plus 10, not good because it's to the fourth power. It's not what I don't want. So those are some examples of linear versus not linear. So we want to talk about adding linear expressions. So both of these are linear because look, x to the first, nothing else is being multiplied other than with the 2, but we're not multiplying with another variable. Okay, and so we'll take a look at this. So I'm going to show you using algebra tiles, which you've probably been accustomed to before. So I'm going to go represent each one of these. 2 x's, 2 unknowns plus 3 that I do know, plus x plus 2 other ones there. So altogether, that's what I have. And I'm going to rearrange these. I say, look, I really have 3 of those green rectangles, and I have 1, 2, 3 plus another 2 of those little orange squares. So altogether, I have 3 x's and 5 constants. So 3x plus 5. That's it. All right, I'm going to show you without using algebra tiles this time. So let's take a look at this one. Look, some people already are accustomed to this. I just wrote it for those students. Say, hey, look, when I subtract something, that's the same as adding the opposite, right? So subtract 4 is adding a negative 4. Subtracting a 7 is adding a negative 7. All right, why did I do that? Just to kind of show you, look, there's a different way I can do this. I could line them up even vertically if I wanted to, right? The 2x and the 3x are like terms, so those together will combine. And the negative 4 and negative 7 are also like terms, or constants, so those can combine. And if I add straight down, I end up with 5x, right, this 5x, and a negative 11. So it's adding together, but again, at the end, I want to get rid of this plus and negative stuff going on here. So we're just going to leave it as 5x minus 11. That would be my final answer. And here's my last one here. Simplify the perimeter. Go ahead and try this one out and see what you get. Okay, now that you've tried it out, let's see if you got what I got. So the perimeter of a shape is to go around the shape. So I end up adding all of those expressions. X minus 1, 4x, 2x plus 3. All that stuff gets added together. Okay, so if I go and rearrange some of this stuff, so I went ahead for those students that you enjoy seeing minus as a plus negative. That's okay. I rearranged that, and then I said, hey, look, I'm going to just go ahead and vertically write this all kind of in one spot here. X plus a negative 1, or x minus 1, 4x, that was this part here, and then 2x plus 3. If I add all this stuff up together, well, I can take care of this left-hand side. That's going to give me 7x. And on the other side, I get positive 2. 3 plus a negative 1 is positive 2. And that would be my expression that would simplify my perimeter. If they actually knew what x was, I don't have to go back now and plug it in here. I can go directly here, plug it in, times it by 7, add 2, and I would find that answer. All right, so this is my attempt to try to make these videos short. I will do another video with extra examples to help you out with this one as well.